Today I'd like to talk to you about designing your own PCB, copper clad engraving plate, tooling plate, that type of thing. This is the plate I made up, and I'll just explain to you the theory behind it and why it's such a fantastic good idea, how CNC4A are taking you to the next level. First of all, I got a standard size piece of PCB or copper clad bit of board. Now, depending on what you're making, how big it is, all that sort of thing, this was the most economical size. And I had some aluminium plate laying around. I decided to make it so as I could clamp it this way and that way, and also so as I could clamp it directly to the table or use a vise. Now, normally on my milling setups, the vise is normally in the machine all the time. So if you get your vise, and let's just say this is a vise here, and you set it up 0, 0. If you want to then put a job in, clamp it up, yep, from that point to 0, 0. But if you're going to put a plate in or something like that, think ahead, and when you machine it, make it to suit your vise and also to suit your setup. So that's what these flats here are for. I milled them down enough so as they were a good grip with the vise, but also I machined them a known dimension from here to here. And also I made it exactly the same both sides. So I can put it in that way and it's the same distance, so I put it in that way. That way, if I'm milling something in the middle, I can just spin it around and it'll still be in the middle. So sometimes you might do an offset, or you might be doing left hand, right hand, all that sort of thing. So think about that when you design it. Make it deep enough so it's a decent grip. Make your material thick enough so as when you machine it, it doesn't bow on you. And when it tighten it up, you don't distort it. So to put it in the vise, put it down, then you touch bottom of the plate to the edge of the vise, so that's 0 that way, and there it's a certain distance apart. I also drilled the holes to roughly match up with the size plate. By that I mean they may be 10mm steps, but they don't start at 0 to 10. Because if your block's 50mm and you drill and tap at 50mm, you got half a thread going into your plate. So if you're using 3mm M3 screws, it's 50mm plus 1.5mm. So that's what you have to work out, your standard size plate. So I can get a standard one, put it in, clip it down, and bang. And for that, I'm using tapered head screws, countersunk screws. And they actually screw onto the edge of the material. So that will keep it even lower. So when it comes in at the start, all I have to do is nip it down, and the taper pushes down on the material and locks it. So if I have to go near the edge, that sort of thing. So that's why they are at that position. So if you've got your ruler, what's this crazy guy's dimension? So that's why it's there. Lengthwise as well, widthwise. These actual stops here are also clamps. Look in that corner, it's like that. Just the minimum amount to grip, 1 or 2 millimeters, that's all you're doing. You're not doing rough cutting on big chunks of aluminium. Then what you do is you slot those clamps. Then what happens is when you get your little tapered screw and it goes into the hole, the taper goes in, and as it tightens, it'll either push it up that way, or if it's touched on there, pull it down. So you make the hole distance where you want it to be clamped. So when the screw is loose, it sets up high, you can put your block in, put your screw in. As soon as you start nipping your clamps down, it pulls it down. That way you don't have to have any clamps sitting on the top. So with the countersunk screws, you measure the head size, and then, like I said, that might be 1/2 mil. You may make it 2 mil. So then you may only be gripping by 1 mil on the head, which is enough. So you set that up, work all that out in your preferred cam package. So you've got a thin lip pulling it down, you've got your thin screws holding it down. Beautiful. You mill away, engrave, cut out, then you might only use half of it. So what happens then? What happens if it goes halfway between the screw holes? You then drill another series of screw holes, but then what happens if it goes halfway between them? So in the end you end up with a bit of Swiss cheese grater, you drop it and it snaps in half on you. You then start making some clamps. And if you watch my video on preferred numbers, you will see why it's got these holes. I milled a little recess in there, almost to the thickness of the material. Not quite, so as it sits on a bit of an angle, so like that, when it's clamped down, and the screw will then push it down on top of the material. So it's in the corners, clamping down. But where do you put your holes? If the material is, say, 49 mil wide and the screw doesn't make it, do you drill a slot in here so as it goes up to 1 mil and 1 mil for the 10 mil gap? What do you do? Well, and what shape is it going to be? Which part are you going to clamp? It's not always going to be square, it may be round in different sizes. So you then design it so as you use the preferred number system. So right next to that groove, it's touching that groove. So it's basically hard up against the material. On the other side, when I flip it over, there's a recess on that side and a recess on the other side. So if you rotate it, it will always clamp. So on the other side, I made the hole 2 millimeters away. So then it's basically 1 mil, turn it over, it's 2 mil. So then I can drill the hole 3 mil the other side above the 1 mil. So then it can be 1 mil, 2 mil, 3 mil. But then with the width of the material, let's just say it's 10 mil, the 1 mil this side is 9 mil when I rotate it over. The 2 mil is 8 mil when I rotate it over. The 3 mil is 6 mil when I rotate it over. And if I make a 5 mil, it's in the middle. So instead of having a slot all the way through, weakening it, making it flexible and snap off and all that, and not pull up, because the other bit then is you use the taper of the screw to start pushing it forward as well. So you get the clamping down position and then you get the forward position from the taper. So using the preferred number system, reduced the number of holes, kept it strong, kept it versatile, and you can see the repeat position of the holes, the pattern of the holes, and you can do that yourself. Also, you have to have a bit of forethought. Some of them are for the long lengths, but they don't go all the way across. You think, why did you do that for? Well, because the holes are not a slot, vertical slot, they offset. So when you move it to the next hole, it moves left and right. So if you made it the right width and you wanted to use that hole, it won't fit. So that's why it's adaptable to spin around and gets the play out. So clamps very strong, very quick, it's repeatable, and it's not that expensive. These are all just hand drilled and hand tapped. Sometimes it's good to get involved with the material and do a bit of physical exercise, and as you can see, it's quite good, quite versatile, looks a bit mechanical, all the screws, but I highly recommend it. With CNC4A taking you to the next level, this is what you can achieve. So as always, thanks for watching. Catch you next time.